You'll recall that the empirical formula is the formula showing the simplest ratio of atoms in a compound, and the molecular formula is showing you the actual number of atoms in a particular molecule. We've learned a few methods how to calculate the empirical formula using percentage composition data and experimental data in order to do so. And what we're going to do now is learn how to use that information and molar masses of the molecules in order to help us to determine the molecular formula. A student a few years ago of mine wrote a song and recorded it explaining the process. So we'll start by having you listen to this song.
Molecular formula shows the number of atoms. To find it, we need the empirical formula. We also need the molar mass. Yeah, that helps. Find the multiplier, you divide the molar mass by the molar mass of the empirical formula. Take the multiplier and multiply it by empirical. Yeah, 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 yeah. Molecular formula shows the number of atoms. Now you've got the molecular formula and the atoms.
As Kane described in the song, in order to find the molecular formula, we need two things. We need the empirical formula, and we're also going to need the molar mass of the molecular formula. Later on in the year, we're going to be learning different lab techniques for finding the molar mass of a compound in the lab. However, at this stage, when you're given the molar mass of a molecule, it will have been determined from using a mass spectroscopy experiment. What you should expect is anytime you're going to be finding the molecular formula at this stage, that it will be given to you in the question. You will not be needing to do some kind of a calculation in order to find it. Now let's look at this conceptually. Both ethine and benzene have the same empirical formula of CH. The molecular formula for ethine is C2H2, while that of benzene is C6H6. Much like their formula is a multiple of the empirical formula, so in this case, the molecular formula is 2 times its empirical formula, and in this case, it's 6 times, the molar mass is going to be in the same multiple. So the molar mass of CH is 13.02, while that of C2H2, if I calculate it either separately using the atoms or by thinking about it in terms of it being a multiple, is 26.04. At the same time, for the C6H6, its molar mass is going to be 6 times that of CH, or 6 times 13.02, which is 78.12. So if we look at a third example, another molecule with a molar mass of CH, and we're given that we have a molar mass of 52.08, we can use this information in order to figure out what the formula is. Because we can figure out what the multiple is that the molecular formula is of the empirical formula. The way that we do that is by finding the multiplier. And as Kane sang, we're going to take the molar mass of the molecular formula, which is in this case 52.08, and we're going to divide by the molar mass of the empirical formula, which in this case is 13.02. What we find here is that we get the whole number 4, and you should always be expecting some kind of whole number here. And so from that information, I can then take the empirical formula and I can find the molecular formula by multiplying all the atoms in the same formula by that same multiplier. So in this case, it would have a molar mass of C4H4. So let's look at a few examples. A compound with an empirical formula of CH2O has a molar mass of 180.18. What is its molecular formula? So as you know, we've got both pieces of information we are required. We need the empirical formula of the compound as well as the molar mass of the molecule in order to determine its molecular formula. Now what you need to recognize from reading questions like this is that when they're talking about the compound or they're giving you some kind of a molar mass, that's making reference to the molecular formula. So in this case, you can use the information from the periodic table for carbon, hydrogen, and oxygen to find that the molar mass of CH2O is 30.03 grams per mole. So to find the multiplier, I'm going to take the molar mass of the molecular formula that I'm given of 180.18, and I'm going to divide by the molar mass of the empirical formula, which is 30.03. That's going to give me a multiplier of 6. So knowing the multiplier and the empirical formula, I can then determine the molar mass of the molecular formula by simply multiplying through. So therefore, the molecular formula is C6H12O6. Now in this example, we were given both of the pieces of information we needed. More commonly, you'll find that you're asked to solve problems where you're given two sets of information. You're given information that will help you to find the empirical formula, and then you're given the molar mass of the compound so that you can proceed to find the molecular formula. So we need to do this in 2 steps. The first step is to determine the empirical formula. We're dealing with nitrogen and oxygen. Okay, we're going to make our assumption here of 100 grams because we've been given a percentage composition. So it's easiest to work with 100 grams so that we've just got 30.4 and 69.6. We're then going to find the moles of each of these elements. So we're going to divide 30.4 by 14.01 and divide 69.6 by 16, and we're left with the moles of each of those elements. To convert this to a whole number ratio, I divide both by the smallest, which is my 2.1699, and I'm left with a 1:2 ratio. So this gives me the empirical formula. So my empirical formula here is NO2. To find the molecular formula, I need to find my multiplier. So I look back to the question and I find the molar mass of my molecular formula, which is 92.0. And I'm going to divide that by the molar mass of NO2. So I need to find this by taking the molar mass of the nitrogen and the molar mass of the oxygen and adding it together. And I find that I get 46.01. And this gives me a nice whole number of 2. So that's my multiplier. So I know, because my molar mass of my molecule is double that of the empirical formula must be doubled in order to obtain the molecular formula.